So we're calling this Notes 0, and it's going to be kind of some prerequisite knowledge to help us get into systems of equations. But in order to do that, we first need to be introduced to two variable equations, and so far we've only been dealing with one variable. So in this set of notes, you're really going to be working on writing your equations using two variables. I think it'll come pretty naturally. A lot of the problems that we're going to do are going to be recalls of problems that we've already done with different numbers. So remember when you helped your friend move and they needed a dolly that cost $5 and the moving truck was $15 per hour? Write a two-variable equation to show the total cost T of renting the truck and the dolly based on the number of hours, H, the truck is rented for. So let's think about this. If I'm renting the truck for an unknown number of hours, H, and I know that it's $15 per hour, then I would multiply 15 by whatever that number is, and then I would add the cost of the dolly. By doing this, I would achieve my total, which means all of this would equal T. So I have my two-variable equation, T representing total and H representing hours. And this shows me that my total cost is going to equal 15 times the number of hours plus 5. Now let's complete the table to see what the cost would be for different numbers of hours. So for 1 hour, I would know that it would be 1 hour at $15 an hour, which would be 15, plus 5 for the dolly would be 20. For 2 hours, that would be 2 hours at $15 an hour would be $30, plus 5 for the dolly would be $35. Pause the video and press play when you're ready to check your total amounts of money for 3 hours and 4 hours. So for 3 hours it would be $50, and for 4 hours it would be $65. That's because 3 times 15 is 45, plus 5 is 50, and 4 times 15 is 60, plus 5 is 65. Now I could continue this table forever, and I could keep finding the total cost for different numbers of hours. Do you think there are any number of hours H that wouldn't make sense to use in this table? Why do you think this? Take a moment to think about it, pause the video, press play when you're ready to hear what we think. So I'd be curious to hear what you came up with. Maybe you said that it wouldn't make sense to have a really large number of hours because it wouldn't take that long to move. You'd probably be right. What I was thinking is that it wouldn't make sense for any numbers to be below 1. Because if you're not going to rent the truck at all, let's say for 0 hours, you're probably not going to rent the dolly. Even more so than that, numbers below 1 are negative, and it wouldn't be possible to rent the truck for a negative number of hours. So I don't think it would make sense to have negative numbers for H. Later on in the year, we're going to talk about this thing called domain and range, which is all the possible numbers we can expect to go into and out of our table. This is just kind of a glimpse foreshadowing that for later in the year. Do you also think you could predict the types of numbers you would see in the row T for total cost? So if I look at my numbers so far, I've got 20, 35, 50, 65. What's going to be true about all these numbers that come after? They're definitely all going to have a 5 or a 0, and they're going to be going up by 15 each time. That's kind of what I was going for there. So it wouldn't make sense to have, say, like a 73 come into this equation. For this example, remember Kim, who worked at the restaurant earning $10 per hour plus tips? Let's write a two-variable equation for Kim with the following information. She earns, that says 8, but let's change it to 10. She earns $10 per hour, plus she usually makes $20 per day in tips. Let's write a two-variable equation to represent the total amount of money that Kim will earn, which we're going to call T, based on the number of hours she works in one day. So pause the video and write your equation. Press play when you're ready to check your answer. So in one day, if Kim works H hours, we can multiply that number by 10, and then don't forget to add her tips, which it says is usually $20. All of this is going to equal her total. Now go ahead and complete your table to see what Kim's total amounts of money would be for different numbers of hours. Press play when you're ready to check your answer. Now remember on the previous slide I asked if there were certain numbers that wouldn't make sense in this table? Of course, we still can't have negative hours, but if we're only working in one day, isn't there at some point a maximum that we could reach? Maybe 24, but that would also mean you're working for 24 hours straight. So just something to think about, that sometimes there's going to be restrictions on numbers that we can put in our table in equations. Now let's imagine that Justin also works at a restaurant. He only makes $8 per hour, so he's making less per hour than Kim, but he usually makes $56 in tips each day. Let's write a two-variable equation to represent the total amount of money Justin will earn, which we're still calling T, based on the number of hours he works in one day, which we're still calling H. Once you've written your equation, go ahead and complete your table and pause the video and press play when you're ready to check your answers. So for Justin's equation, I got total money would equal 8 times the number of hours plus 56. For 1 hour, this would be $8 plus his tips, which would be $64. For 2 hours, this would be 8 times 2, which is 16, plus his tips, which is 72. And you can see it's going up by 8 each time. So I can see from my tables that for 1 hour, Kim only makes $30, while for 1 hour, Justin makes $64. Do you think there'll ever be a time where their amounts of money would be the same? Pause the video to think about that question and put your answer here. Press play when you're ready to check your answer. So what I was thinking is that since Kim makes more money per hour, remember she makes $10 per hour where Justin only makes $8, she's eventually going to catch up. And what we're going to be doing in this unit is finding the exact moment or the exact number of hours that it would take Kim to catch up to Justin. We've actually already seen this foreshadowed a little bit when we've talked about how many baskets player A and player B would need to score on those spreadsheets, or how many times visiting the botanical gardens you would need to make them the same cost for a member and non-member. In fact, I think we might even see that one again really soon. So here's one more equation that we're going to remember. It was when you were saving money and your sister was spending money. These numbers are all exactly the same. You had $80 and you were saving $6 per week, while your sister had $145 and she was spending $7 per week. Now let's write two equations, one for you and one for your sister, to show how much money, which we're going to call M, you'll each have in W weeks. Pause the video to write an equation for you, write an equation for your sister, and press play when you're ready to check your answers. So for your equation, your money is going to equal your starting amount plus $6 each week since you're saving $6. For your sister, it's going to be your money equals $145 minus $7 each week since you're spending $7. I actually used the wrong variable. These should have been W. So now for my next question, it says, who starts with more money? Well, clearly my sister does. Do I ever think that there's going to be a time when we are going to have the same amounts of money? Why do you think this? Pause the video, write down your answer, press play when you're ready to check. So my thinking was that yes, at some point we'll have the same amounts of money because you are saving, your money is going up, while she is spending, which means her money is going down. Now let's look at this graphically. Below are the two graphs both graphed on Desmos. One's the red line, one's the blue line. Which line do you think is your money, and which line do you think is your sister's money? In this space, explain your thinking using complete sentences. Pause the video, press play when you're ready to check your answers. So don't worry if you didn't say exactly what was said here, but some things you might be looking at are the fact that the red line, which is going to be you, starts at 80, this is 50, 60, 70, 80, and it's going up. And the fact that it's going up matches that we're saving money. Your sister is going to be the blue line because it starts at 145, and since she's spending money, it would make sense that it's going down. Remember the gardening club where you could be a member if you paid a fee of $24, but then that meant you only had to pay $3 each time you wanted to go to the garden? Or you could choose to remain a non-member and not have to pay a fee, but you'd have to pay $6 each time you go. Let's write two equations, one for members and one for non-members, to show the total cost, C, that they would each pay for V visits. Pause the video, write your member equation and your non-member equation. Press play when you're ready to check your answers. So for members, their total cost would equal $24 plus 3 times for each visit. For non-members, their total cost would equal $6 for each visit. Which option is cheaper at first? That's going to be the non-members, because at first, they don't have to pay the upfront fee. Do you think there'll ever be a time that members and non-members would pay the same price? Why do you think this is? Pause the video to think about your answer and write it down. Press play when you're ready to check your answer. So yes, I think there's going to be a time where they would pay the same price because non-members pay $6 each time and members only pay $3. So non-members are going up at a faster rate. Let's look at the graphs graphed in Desmos and compare. I've got a green graph and I've got a blue graph. Which graph do you think represents the member and which graph do you think represents a non-member? Explain your answer using complete sentences. Pause the video, press play when you're ready to check your answers. So an example of an answer that you might give would be that the green graph represents the non-members because it starts at 0 and it's going up at a faster rate than the blue graph. The blue graph represents members because it starts at 24 and it's going up slower than the green graph. Don't worry if your answer doesn't match perfectly. We're just starting to investigate how graphs and equations match up. The last thing that we're going to do today is we're going to go from tables of data to graphs and points on a graph and connect them with a line. So first we're going to complete the table below by substituting x into the equation to find y. The first one has been done, but we'll talk about that one together. Then we're going to create ordered pairs in the form x, y, and again the first one has been done for you. Then we're going to graph the ordered pairs in the coordinate plane. So let's look at the first one. So my first x value is -2. So that would mean that I'm going to replace x with the value -2. Down here I've done that. So 2 times x, and I've replaced that with -2 plus 1. If I do all this math, I'm going to get y. 2 times -2 is -4, and then I bring down my plus 1. Remember, I have to follow PEMDAS. -4 plus 1 is -3. So for my ordered pairs, the x value was -2, and the y value that I got was -3. Now if I were going to graph that on the coordinate plane, remember to graph an ordered pair, I first graph along my x-axis, that's my horizontal axis, and then I graph the second number along my y-axis, which is my vertical axis. The first number tells me to move right or left. If this were a positive, I would move right, and if it's negative, I'll go left. So since it's -2, I'm always going to start at the origin, which is 0, 0, and I'm going to go 1, 2 to the left. My second number is -3. Since it's negative, I'm going to go down on my y-axis 3 spaces, and I'm going to put a point right there. That's my first ordered pair. So at this point, pause the video, try it for the remaining 4 x values, be sure to fill in your y's, complete your ordered pairs, and then graph. And what you should see is that your pairs should form a line. Pause the video, press play when you're ready to check your answer. So after replacing x with -1, 0, 1, and 2, and doing all the math, my y values were -1, 1, 3, and 5. And so here are my ordered pairs. I only used colors just to help you see which of the dots would match up. You don't have to do that. But if you look at my graph, you'll see that all of my points lie in a line. And so the next thing that I would do is I would take out a ruler and I would connect this with a straight line, and I'd have arrows on both ends to show that my line could go on forever in both directions. We're going to do a lot more with graphing lines later, but for right now, we just want you to know that when you have data in a table, we can also take that data over to a graph. So on example 6, you're going to do exactly what we did on example 5. You're going to replace x with each of these 5 numbers to find what y would be. You're going to create your 5 ordered pairs, and then you're going to graph them in the table. Pause the video, press play when you're ready to check your answers. So here, when I replaced x with -2, I got 3 times -2 is -6, and then -2, you'll see I did keep change opposite to help me maintain all my signs and not make any errors. So to graph the ordered pair to -2, -8, I went 2 to the left and 8 down. 3 times -1 was -3 minus 2. Again, I did keep change opposite to get -5. And to graph -1, -5, I went 1 to the left and 5 down. 3 times 0 is 0. 0 minus 2 is -2. So to graph the ordered pair 0, -2, I don't move left or right, and I go down 2. When x was 1, 3 times 1 was 3, minus 2 is 1. And to graph the ordered pair 1, 1, over 1, up 1. And then lastly, 3 times 2 is 6, minus 2 is 4, and to graph the ordered pair 2, 4, you go 2 to the right and up 4. And you'll see that all of these points lie on the same line, which is really good news.